Okay, guys, today we're talking about volcanic eruptions and hazards. Have your note ready to go. So, what is fallout in the sense of a volcano? It is the amount of ashfall, the ash that lands in a specific area. So, when Mount St. Helens erupted in 1980, they had 2 to 5 inches of ash right around the volcano. But because of the way the winds blew, they also had 2 to 5 inches all the way over here. They had up to 2 inches in all of the orange area, and then they had trace amounts as far as North Dakota and the very top of Wisconsin there. No, that's not Wisconsin. Yes, it is. Okay, moving on. Okay, so ashfall, it looks a lot like snow. It can be a lot heavier, though, as we will talk about later. This is the Philippines in 91, where they would normally never see anything that would resemble snow. Parts of the volcano to know, the main vent would be where the majority of the volcano is going to come out, magma is going to come out of. A side vent would be where some of the pressure gets let off the side here. The cone would be the normal shape of the volcano. A conduit is anything that has the magma in it. The magma chamber, of course, is a large chamber underneath the volcano where the magma is accumulating. And a volcano is a region of the Earth's crust where the magma, the liquid rock, has pushed its way up to the surface. Where do we find the volcanoes? We're going to find them at the subduction zones. Remember, that's where the continental oceanic convergent boundaries occur, so not too far from an ocean. Divergent zones, which are usually in the middle of the ocean, and hotspots. These can pop up anywhere where the crust is weak and thin, often in the middle of the plates. We have not talked about hotspots yet. So, hotspots is a location on the Earth's surface that has experienced an active volcanism for a long time. Where this weak spot here, there's a hot mantle plume, which actually causes the oceanic crust to melt, and you create the volcano. The Hawaiian Islands are the example of hotspot volcanoes. And then what happens is you get the volcanoes forming, and then eventually the old ones get worn down, and there's just a constant renewal of the volcanic islands. Notice that the hot spot is stationary. It's the oceanic crust which is moving very slowly over time. Types of volcanoes. You have an active volcano, which has had at least one eruption in the past 10,000 years, or has a magma chamber that is still active. And then a active volcano can be erupting or dormant. So if it is erupting, it is having an eruption right now. And if we click on this website, we can actually see every erupting volcano on the planet right now, and all of those that are considered active but not erupting. A dormant volcano is an active volcano that is not erupting but is supposed to erupt again. Mount St. Helens, not erupting right now, could potentially happen again, as far as I know. An extinct volcano has not had an eruption for at least 10,000 years and is not expected to erupt again in the foreseeable future. Kind of like a dinosaur. Not expected to come back. It is extinct. Pacific Ocean, we find what we call the Ring of Fire. It is a direct result of the plate tectonics and the movements of those plates in that area. Notice how many volcanoes there are. 452 volcanoes, over 3/4 of the world's active volcanoes. How cool is that? On your notes, you will see a map that looks similar to this. Go ahead and draw, if you have a highlighter, even better. Starting, this is Australia, where you can find this ring of fire. So it starts way down here. This is New Zealand. Following along, here's the Guinea Islands. Up towards Japan. There's Japan. All the way up that coast there. This is part of Russia. And then here's the islands that lead us into Alaska and all the way down the north coast, the west coast of North America, all through Middle America, and all the way down the western side of South America as well. Notice not only is it a hot zone for volcanoes, but they have major earthquakes as well. So if you want to live in a very active plate tectonic area, here's where you want to live. If you don't want earthquakes and volcanoes, these would be areas you might want to avoid living. And here's all these dots are volcanoes. It's just a different picture. And notice how the volcanoes are at the margins, which means the edges of the plates. And here's Australia. And then this shows a little bit more on how this plate also has the volcanoes going off that side. And in class, I will probably show this video. It's a really cool video because we had all sorts of cameras pointed at Mount St. Helens. We knew it was going to erupt, and so we have really good footage of the before and after on that. Explosive eruptions can send ash clouds all the way up into the stratosphere, which cause severe environmental and climatic effects. There have been volcanoes that have gone off and basically caused summer to not happen because it has put so much ash in the air that's blocked the sun for the whole summer. So if you are interested in that, when we get to the plate tectonic project, you may want to look into that. I can help you find which volcano that was. Other problems from explosive eruptions, just the ash fall. This town is almost buried. It can collapse roofs. It can bring down your power lines. If you're really close to it, the ash is hot and it'll kill the plants that way. But of course, it can bury the plants. If you talk about 3 feet of ash, it's kind of hard for plants to get through that. It can contaminate your water because you're not going to want to drink anything that 3 feet of ash lands into. And if you breathe that in, it actually goes into your lungs. It's really super fine particles. It mixes with the moisture in your lungs and forms like a concrete mixture, and you suffocate. So ashfall is not a pleasant thing. There's more pictures of ashfall. Pyroclastic flow. This is really nasty. These things go so fast that it can move faster than that vehicle there. And it's super hot and it's toxic. So it will burn your lungs out before you die of the toxic gas. I don't know if that's good news or bad news. And so if you see anything like that, hope you are farther away than the people in that vehicle. So pyroclastic flow just burnt those trees. Everything on those trees are dead. Maybe the inside of the trees is alive enough to recover. The other thing we can get from explosive eruptions that we probably haven't heard of before, lahars. So this is when it melts and mixes with snow and ice and a lot of water. So now we have like almost a concrete mixture, and it forms these high flowing, fast moving, almost like rivers of concrete, and it will knock out anything in the path. So here's a picture of it. It looks like concrete there, right? Just flowing down and taking out everything. Here it's taking out a bridge that was a bridge. It's not a bridge anymore. So law hairs are different because it's water. So pyroclastic flow is just super hot air, and this is a cloud of it. So cloud of super hot air, toxic. This stuff is like liquid concrete, but it's flowing fast because there's a lot of more water mixed in with it. Now, effusive eruptions are slow, and that sounds good, right? Sounds so much safer than a pyroclastic flow. That does give you more time to leave. Pack your things, get out. But the lava will melt anything in its path. So here's some cars that people didn't get out of the way in time. The lava itself is in excess of 392 degrees Fahrenheit. How hot is that? It's hot enough to melt bone. There is nothing left of organisms that are in the way. So your croplands are destroyed, plants, trees, burn down your house because it's going to catch your house on fire. It's slow, but it will destroy any property that you have that's in the way. Can we tell? Can we get out of the way, right? Can we get out of there? Yes. So there's many signs, tremors of the volcano. So the ground starts to shake. The volcano itself will start to grow because the magma is pushing and there's often an increase in gas and heat. So the volcano becomes hot to walk on. Sometimes it will start spitting things out of the volcano, rocks, small pieces of gravel, sometimes even magma will sometimes start leaking out. Believe it or not, Pompeii, I think a lot of you in their world history may have come across Pompeii by now or heard about it in some other history class back in middle school. A lot of these were described by the people of Pompeii. They talked about the mountain shaking and being angry and spitting rocks at them, and how the ground was so hot they could feel it through their sandals. And yet they stayed there until the pyroclastic flow went through Pompeii and literally wiped out the whole town. Again, when we get to the project, plate tectonic project, if one of you groups are interested in the volcano that did that, we can help you find that one. Here's one of the instruments we can use to measure. A tilt meter sounds just like it is. It measures the tilt of the ground. The new ones have GPS and electronic devices that will send the signal directly to wherever the humans are, so you don't have to go out and check it. This one is a very simple one where you just check the level, just like a level in your house when you want to hang a picture straight. But this is a little more sophisticated than that, more accurate. And this is how the tilt monitors work. Gas monitors, they go in and they collect the gases. And then you do have to be careful because sometimes some of those gases include methane, which is not healthy for humans to be breathing at any specific time. We also can use the seismographs, which we use in earthquakes as well. And so those measure the tremors that we talk about, the shaking of the ground as the magma and the gas start causing the volcano to move. So, in summary, volcanoes are extremely hazardous, but we can study them, monitor them, and understand each one of them. And every volcano is different, and each one has unique dangers. And we can also put plans in place so we can help understand their potential damage and limit their potential damage. And that is all we have to say about that. And we will